Section 7.2, Estimating a Population Mean. In this section, we are trying to estimate mu. We don't know what mu is, and we are trying to estimate it. Point estimate. The sample mean x bar is the best point estimate for the population mean. Confidence interval. Use sample data to construct and interpret a confidence interval estimate of the true value of a population mean. Sample size. Find the sample size necessary to estimate a population mean. These are the three concepts that we are going to cover in this section. Notation. Mu is population mean. N is the number of sample values or sample size. X bar is the sample mean. E is margin of error. S, sample standard deviation. Here are the two requirements to construct the confidence interval for population mean with sigma not known. The sample is a simple random sample. Either both of these conditions are satisfied. Either the population is normal or n is greater than 30. Here is the formula of margin of error. E equals T of alpha half times S over square root of n. Whenever we are working on T distribution, we need to have a degree of freedom. Degree of freedom equals to the sample size minus 1. T of alpha half is the critical value T separating an area of alpha half in the right tail of the student T distribution. Degree of freedom is df equals n minus 1. Here are the roundup rules for constructing the confidence interval for population mean. If you're given the original data, round the confidence interval limits to one more decimal place than is used for the original set of data. If you're given the summary statistic, then round the confidence interval limits to the same number of decimal places used for the sample mean. Example 1. Find the critical value T of alpha half corresponding to a 95% confidence level given that the sample size has n equals 15. My confidence level is 95%, which is 0.95. That makes my alpha is 1 minus 0.95, which is 0.05. Alpha divided by 2 is 0.05 divided by 2, which is 0.025. To find T of alpha half, we are working with the T distribution. The T distribution looks similar to the normal distribution. This is T. Confidence level is the area in the middle, which is 95%. This little small area, add to this little small area, add to 95% is 100%. So this small area plus this small area is 5%, which is 0.05. So each one of these is 2.5%, which is 0.025. And this is T of alpha half, which is T of 0.025. In order to use the T distribution in the StatCrunch, I need my degree of freedom. Degree of freedom equals n minus 1. And my n is going to be 15. So I have 15 minus 1. Degree of freedom is 14. And I am going to use StatCrunch to find my T of 0.025. To use the T calculator on StatCrunch, we click on Stat, Calculators, and T. In here, we need the degree of freedom, which is 14. And we know the area to the right is 0.025. And because this is the area to the right, we're going to change this into greater than. And this is my t-value, 2.1447867. T of 0.025 equals to 2.1447867. Please read the instruction to see how many decimal places you should round this to. I am going to just round it to 2 decimal places for this problem. Example 2. 30 randomly selected students took the calculus final. If the sample mean was 95 and the standard deviation was 6.6, construct and interpret a 99% confidence interval for the mean score of all students. I have my n equals 30. My sample mean is 95. Standard deviation is 6.6. And this is the sample standard deviation. Confidence level is 99%. I am going to use StatCrunch to find my confidence interval. To find the confidence interval for population mean with summary statistic, we click on Stat, T-Stats, one sample with summary. Sample mean, which is X bar, 95. Sample standard deviation, which is S, 6.6. Sample size, which is N, 30. We are going to choose this and change the level to 99%. Compute. This is my lower limit and this is my upper limit. My confidence interval is 91.678584 and 98.321416. If there is an instruction on how to round, please follow the instruction. In this problem, there was no instruction on how to round these numbers. Now I have 2 case scenarios. One is when the raw data is given. 2, when is the summary statistics is given. In this problem, I'm given the summary statistic. So I will round these 2 numbers to the same number of decimal places with my sample mean. Sample mean is whole number, so I'm going to round these 2 numbers to whole numbers. My confidence interval is from 92 to 98. What does that mean? This confidence interval is the interval that I use to estimate my mean score for all students. I am about 99% confident that the mean score for all students will be in between 92 and 98. Example 3. The football coach randomly selected 10 players and timed how long each player took to perform a certain drill. The times in minutes were 7.1 minutes, 10.7 minutes, 9.3 minutes, 8.6 minutes, 11.3 minutes, 7.8 minutes, 6.9 minutes, 11.5 minutes, 10.9 minutes, and 12.9 minutes. Construct and interpret a 93% confidence interval for the mean time for all players. I am given the original data here. I don't have my X bar, I don't have my S, I don't have my N. And I want to find a 93% confidence interval. I am going to use StatCrunch for this. If you're given the original data and you want to import that into StatCrunch, you're going to click on this little square right here and choose Open in StatCrunch. They will import the data here for you. I'm given the original data, so I need to enter the original data into the StatCrunch before I start calculating. These are my data values, and I want to construct a confidence interval for the population mean from these data values. Stat, T-Stats, one sample with data. This is a column where I save my data values. I'm going to choose it. Down here, I am going to select the confidence interval and I am going to change the level into 93%. This is my lower limit, and this is my upper limit. My confidence interval is 8.36-33786 to 11.036621. How many decimal places should I round? Again, if there is an instruction on how to round, please follow the instruction. In this problem, there was no instruction. I'm given the original data. These values have one decimal place. I am going to round these limits to 2 decimal places. What does it mean? It means that the mean time for all players would fall in between 8.36 minutes and 11.04 minutes, and we are 93% confident. If you're given a confidence interval with the upper limit and the lower limit, you can also use the same rule as we learned from the previous section to find the point estimate and the margin of error. To find the point estimate, you take the upper limit plus the lower limit divided by 2. To find the margin of error, you take the upper limit minus the lower limit divided by 2. To find the sample size required to estimate a population mean, we are using this formula. N equals Z of alpha half times sigma over E squared. When computing the sample size, if N is not a whole number, we always round it up to the next larger whole number. Example 4. Assume that we want to estimate the mean IQ score for the population of statistics students. How many statistics students must be randomly selected for IQ tests if we want 95% confidence that the sample mean is within 3 IQ points of the population mean? Assume that the population standard deviation is 15. We are wondering how many students should we select it for the IQ test. So we are looking for N. And we want that the sample mean is within 3 IQ points of the population mean, which is the margin of error is 3. Sigma is 15. N equals Z of alpha half times sigma over E. Square. I have sigma is 15, I have E is 3, I'm missing Z of alpha half, so I need to look for Z of alpha half. So confidence level is 95%, that makes my alpha is 1 minus 95%, which is 0.05. I'm having a standard normal distribution. Mean equals 0 and standard deviation equals 1. 95% is the area in the middle. This little left tail and this little right tail add up to be 5%. So each one is 2.5%, which is 0.025. And I want to find this number. I am going to use StatCrunch for this. To find the z-score, I need to use the normal calculator. Stat, calculators, normal. My mean is 0, my standard deviation is 1. The area to the right is 0.025. And because this is the area to the right, so I'm going to choose this to greater than. And this is my z-score. And I got 1.959964. I am rounding the z-score to 2 decimal places. So that is 1.96. And I can substitute 1.96 in here. and I got n is 96.04. And when n is a decimal, I will round it up to the next larger whole number, which is 97.